All right, strap in everyone, because today at Linkfitty we are going deep on AI and coding. We're diving into a paper called SWE-Lancer, Can Frontier LLM Earn $1 Million from Real-World Freelance Software Engineering?
It's a really cool paper, really interesting. It takes things in a different direction.
Yeah, we're talking about real-world applications, not just, those theoretical coding challenges that we see so often.
These theoretical stuff, yeah.
Exactly.
This is like throwing AI into the freelance G economy.
It is. It's like, okay, you asked the coding boot camp.
Right?
Can you actually, do the work?
Can you make money?
Yeah, can you make money? And they didn't make it easy for these AIs. The researchers built this benchmark called SWE-Lancer, and they used over 400 real tasks from Upwork. That represents $1 million in potential payouts. They wanted to see if these cutting-edge AI models could actually, earn money as freelance software engineers.
And they didn't just pick any old freelance platform. They went with Upwork, which is like the big leagues for freelancers. It's serious business. And they sourced these tasks from a real company. Expensify, a company with millions of users.
Right, real-world problems.
Real problems.
Not toy examples.
Not toy examples. Exactly. So let's jump right into the paper.
All right, let's do it.
Page 1, the abstract. Right from the start, they lay out what SWE-Lancer is all about. It's a benchmark. It's designed to see how well large language models, or LLMs, can handle real freelance software engineering tasks.
And they get right to the point with a key finding, too.
Yeah. Even the most advanced AIs, they're still having trouble solving most of these real-world tasks.
Right, there's a gap, a big gap.
I think, yeah.
Between what AI can do in a lab setting and what it takes to be a professional software engineer out there in the wild.
Sobering thought, but an important one.
Absolutely, it's a reality check.
Yeah, it is. All right, so let's move on to page 2.
Right, the introduction. Now, this section digs deeper into why a benchmark like SWE-Lancer is so important, right? And it highlights how the field needs benchmarks like this. They need benchmarks that can truly push these AI models and assess their capabilities. AI has become really good at solving those simplified coding challenges we see in a lot of these online coding platforms, those competitive programming things.
Right? The kind of stuff you might see in a coding interview. Exactly.
Or like a very specific, test.
Right. But real-world software development. It's messy, it's complex.
It's not just
algorithms on a whiteboard.
Exactly, yeah. So SWE is all about addressing that complexity.
It gets at the heart of what it means to build software in the real world.
I mean, in real projects, developers have to work across the entire technology stack, right? I mean, from front-end user interfaces.
Front-end, back-end.
To back-end databases.
Databases, APIs, the whole thing.
The whole 9 yards. And they have to understand how all these different parts, how they interact with each other. I mean, we're talking about complex code bases.
Complex systems, yeah.
So it's not just about writing a few lines of code. It's about understanding how those lines fit into this much bigger picture, which can get very intricate. All right. So now let's move on to pages 2 and 3, where they really start to unpack what makes SWE-Lancer so unique.
Okay. So one of the key things is this. They use real-world payouts to actually quantify how valuable each task is.
Okay. So we're talking about actual dollar amounts here.
Actual dollars.
Not just points on a scoreboard.
Right? By tying it to what people are actually paid on Upwork, they give us this concrete way to measure how much an economic impact these AI models could potentially have in the world of software development.
That's really interesting. So it's not just about passing a test. It's about how much is that AI's work actually worth. Exactly. And I think that's going to be super fascinating when we get to the results section.
Yeah, I'm very curious to see how that plays out.
But there's another unique thing about SWE-Lancer, and that is it includes these management tasks. So the AI isn't just writing code. It also has to evaluate technical proposals, just like a human tech lead would have to do in a real company.
So it's like, can AI not only be the coder, but also like the project manager, or at least,
The team lead, the reviewer, the decision maker.
Exactly. So that adds a whole other dimension, right?
It really does. It's not just about individual coding skills. It's about understanding project requirements, assessing technical solutions, making decisions.
Right? So then we get to page 3, and this is where they really zoom in on this concept of end testing. And this is where things get really interesting, I think.
Absolutely. This is where the rubber meets the road. Yeah.
End-to-end testing. It's all about making sure that the AI solution doesn't just, pass some basic checks. Like, does the code compile?
Right. It's not just about checking the syntax.
No. It's about making sure it actually works when a user interacts with the application.
So it's like the difference between, passing a written driving test and actually being able to drive a car in traffic.
Exactly. And testing. It makes sure that the AI solution isn't just theoretically correct. It's got to be practically functional.
It's got to work in the real world.
It's got to work. And that's why it's so crucial for a benchmark like this, because it prevents the AI from kind of like cheating in a way, finding these shortcuts that might work for a simple test, right?
But totally fall apart in a real-world application.
Yeah, it's got to be more than just like, memorizing answers or finding these like little tricks, right? It has to actually solve the problem as intended.
To solve the problem? Okay. So then we move on to pages 3 and 4, and they continue to highlight these advantages of SWE-Lancer. And one thing they really stress is how grounded it is in the economic realities of software development.
Right? This is not just an academic exercise. They're dealing with real-world problems, real-world money.
Right? And they really emphasize how high value these tasks are.
High value.
So we're not talking about like little toy problems.
No, this is serious stuff.
This is serious stuff.
It mirrors what freelance developers are actually working on and getting paid for.
Right. So this is designed to assess the AI ability to perform at a professional level.
Professional leveled.
Where the stakes are high, solutions have to be robust, they have to work, and they also again highlight the importance of testing the AI's ability to act as a technical lead.
A technical lead?
And that gives us, these really interesting insights into the potential impact of AI on the workforce, right? I mean, it's not just about automating individual tasks, it's about how AI might fit into these team dynamics and decision-making processes.
Exactly, and it's a topic that's, going to come up again and again as AI keeps evolving.
Absolutely. So now let's go behind the scenes, right?
Pages 4 and 5 take us into the construction of this benchmark.
The nuts and bolts.
And it was clearly a very meticulous process.
They really took their time to make sure that the tasks they included in SWE-Lancer were top-notch.
Right? They started with the Expensify repository, but then they went through this really rigorous process to select and refine the task. They wanted to make sure that everything was, defined, solvable, and actually representative of real freelance work.
It wasn't just, hey, let's grab some random code and throw it in there. They had multiple expert software engineers look at each task, make sure it made sense, made sure it was challenging, made sure it reflected what was going on in the real world.
So they really set a high bar. I mean, for both the AI and the benchmark itself.
They did. They wanted this to be a real test, a true evaluation of what these AI models could do.
Right. And they also had to develop all these end and test.
Right? The tests themselves were a huge engineering challenge. Brought in a whole team of professional engineers to build these tests that accurately simulated real user interactions.
So it's almost like they were building a whole testing infrastructure alongside the benchmark itself. That's quite an undertaking.
It was. They went all out to make sure this was the real deal.
So now I'm really eager to see how the AI actually performed on these challenges.
So, pages 5 and 6, this is where the AI competition really begin. They set up this controlled environment, put these models to the test.
Right. This is where we get to see if all that prep work paid off.
Right? And they were very careful in their experimental setup. To prevent any, cheating, no accessing the internet, no outside resources.
The AI had to rely on its own skills.
Right? Had to prove itself.
Had to prove itself.
So, it's like a high-stakes coding exam where the AI is completely isolated and has to show what it's really made of. So, let's get to the results. Did any of these AI models earn that $1 million prize?
That's the big question, isn't it? Well, not quite $1 million. Even the best model, Claude 3.5 Sonnet, earned significantly less than the full prize pool.
Okay, so no $1 million AI coders just yet.
No.
But AI isn't ready to take over the freelance coding world. At least not yet. Yeah.
But they talk about this thing called pass-at-one accuracy. What is that exactly?
Pass-at-one accuracy. That's the percentage of tasks that the AI solved correctly on its first try.
Okay.
Just like in a real freelance setting.
One shot.
You get one shot to impress the client, deliver a working solution.
No second chances.
No second chances. This is the real deal.
That's tough. And how did they actually calculate the earnings for the AI? How did they figure out how much money it made?
So they used those actual payouts from Upwork. So if an AI completed a task, let's say it was worth 500, it earned 500.
So it's like a direct mapping. Direct mapping to the real world. So we're not just talking about theoretical success or failure. We're talking about, could this AI actually generate income in the real freelance market?
Okay, so spill the beans. What were the actual numbers? How much money did these AAs actually rake in?
All right, let's look at the scoreboard. So across the entire SWE-Lancer benchmark, right? Both those independent coding tasks and those managerial tasks, the top earner was Claude 3.5 Sonnet.
Pulled over 400,000.
Not bad at all. But still less than half of the total potential.
Yeah, still a ways to go. What about the other models? How do they do?
Well, GPT-4 and O1, they both earn considerably less. They really seem to struggle with those independent coding tasks, highlighting the challenges that still exist when it comes to AI tackling real-world software development.
So even among these cutting-edge AIs, there's still a pretty big performance gap?
There is.
Yeah. So is it just a matter of raw processing power? Do the models with more computing power just perform better?
That's a great question, and they actually looked into that. On page 6, they dig into whether giving the AI more computational oomph during the test actually led to better results. Think of it like, giving the AI a faster processor, more memory, more muscle to handle those complex calculations.
So did a bigger brain translate to better coding chops?
It did to a certain extent. They found that increasing the computational power actually did help, especially on those harder, higher paying tasks. Like giving the AI the tools it needs to really grapple with those more complex coding problems.
That makes sense. I mean, some of those problems probably require some serious computational firepower to even analyze, let alone solve.
Exactly. But they didn't stop there. They also explored other factors beyond just computational power.
Oh, okay.
Well, one interesting experiment they ran was giving the AI multiple attempts to solve a problem. Kind of like letting it go back, revise its code, make improvements, just like a human developer might do. You don't always get it right on the first try.
Right, multiple iterations, try different approaches. So, did giving the AI more chances actually improve its performance?
Degree, yeah? Especially for Zone 1. Giving it more attempts led to a significant boost in its success rate. But even with those extra tries, the AI still wasn't matching human-level performance on a lot of these tasks.
So there's still this gap between like AI coding and human coding.
There is, for sure.
But this whole idea of letting the AI iterate, that's really interesting. Like, is that the key to kind of bridging that gap, do you think? Did they explore any other ways to like help the AI better understand the problem and improve its performance?
Yeah, they did. On page 7, they introduced this really cool concept. They call it a user tool. Oh,
A user tool, I'm intrigued. What is that?
it's basically a simulated environment where the AI can actually see how its code changes are affecting the application in real time. It's like giving the AI a way to interact with the software it's building just like a human developer would.
So it's like giving it a visual representation of what's happening.
Exactly. It gets to see the results of its work. It's not just blindly writing code. It's seeing the impact.
So it can be like, oh, if I change this line of code, this happens over here. That's really cool.
And this turned out to be super helpful. Those stronger AI models, like Claude 0.5 Sonnet, they were able to really leverage this tool to understand the problem better, make adjustments, and come up with more effective solutions.
So it's like giving the AI that real-time feedback loop, which helps it learn and improve just like a human developer would.
Exactly. It's all about that feedback, that iterative process.
But even with these tools and multiple attempts, some AI models were still having trouble. Did they find any insights into why certain models just couldn't crack these real-world coding challenges?
And Page Sudden delves into this, exploring the AI strengths and weaknesses, giving us a peek into how these AI models actually approach these coding problems. It's like looking under the hood.
All right, let's pop the hood. Let's see what makes these AI coders tick. What are they good at? What are they not so good at?
Well, one surprising thing was how good the AI was at identifying the root cause of a problem. It could quickly scan through these massive code bases and pinpoint the relevant files, the functions, the lines of code where the issue was, often much faster than a human developer could. So the AI is like a super sleuth when it comes to debugging.
A real code detective. But here's the interesting thing. If it's so good at finding the bugs, why does it struggle with the solutions?
Yeah, that's a good question.
Is it a lack of creativity? Is it missing some sort of human intuition?
It's like, can it diagnose the problem, but then not figure out how to fix it?
Exactly. And that really gets to this fundamental difference between how AI and humans approach coding. The AI, it's great analysis. It spots patterns, identify errors, but when it comes to actually crafting solutions, especially those that are both effective and elegant, it often falls short.
So it's like the AI is a brilliant diagnostician, but maybe needs a little more work on the prescription side of things.
Yeah, that's a good way to put it. Humans with their experience, intuition, understanding of software design principles, they're still better at crafting those elegant solutions.
Right? So AI is advancing rapidly, but it's not quite ready to replace human ingenuity and experience. Just yet.
Not quite. There's still a ways to go.
Now, on pages 7 and 8, the researchers acknowledge that even a benchmark as impressive as SWE-Lancer has its limitations.
Right? No benchmark is perfect.
And they point out that, SWE-Lancer focused specifically on the Expensify codebase.
Right.
It's a large, complex codebase, but it's still just one example of the many different types of software that are out there.
Right? So testing the AI on a wider variety of code bases, different programming languages, different software architectures that would give us a more well-rounded view of its true capabilities.
Yeah. It's like testing a chef's skills, not just in like one kitchen, but across a range of culinary styles and ingredients.
Exactly. You need to see how they perform under different conditions.
And they also highlight the need to test AI on a broader range of tasks, including things like infrastructure, and DevOps work, which are becoming increasingly critical in modern software development.
Right? It's not just about building the application anymore. It's about managing the infrastructure, deploying the code, automating processes. It's about keeping the whole system running smoothly.
Right? The whole life cycle.
The whole life cycle. Testing AI in those areas would give us a much better understanding of its potential impact on the entire software development process.
So that brings us to page 8 and the million-dollar question. What does all this mean for the future of software development?
The big question.
The big question. Yeah, I mean, we've been talking about these technical details, but let's step back and look at the big picture. What are the broader implications of AI's, growing influence in the world of coding?
Yeah, it really is the million-dollar question. Where is this all going?
Right. Do you see a world where AI is writing all the code, or is it more like a collaborative future where AI and humans work together?
Well, the researchers actually tackle that very question. They talk about both the potential benefits and those concerns that come with AI playing a bigger role in software development. On the plus side, they see AI as a way to automate a lot of those really tedious, repetitive tasks that, let's be honest, a lot of developers just don't enjoy doing.
Right? I can definitely see that. Nobody likes doing the boring stuff.
No, nobody does. So AI could free up human developers to focus on those more creative, strategic aspects of software creation, the stuff that really requires human ingenuity.
So it's like AI handling those, more routine tasks.
The grunt work.
So humans can do the stuff that's actually fun and interesting.
Right. Exactly. It's about using AI to, make our jobs better, not replace us entirely.
Make it more fun.
More fun, more efficient, more fulfilling.
Right? But of course, there's always the other side of the coin, right? I mean, there are concerns about, what happens to the job market if AI can automate a big chunk of software development.
That's the big question, isn't it? It's not just about the technology itself. It's about how that technology changes the world, the economy, people's lives.
Right? If AI is writing the code, what happens to all the people who used to write that code?
Exactly. And the researchers don't pretend to have all the answers. They just emphasize that we need to think carefully about these potential consequences. How do we make sure that AI benefits everyone, not just a small group? How do we prepare people for these changes and help them find new opportunities? It's not easy, but it's important.
Yeah, these are big questions we as society need to figure out. It's a good reminder that technological progress, it's not just about building cool stuff. It's about understanding the impact that those cool things have on the world.
It's about the human side of things.
Yeah. Now, before we wrap up, I want to mention that page 9 of the paper actually takes a moment to acknowledge all the people who made this research possible.
It's a great touch. It's so important to recognize the human effort behind these big AI breakthroughs. It's a reminder that AI development isn't just about algorithms and data. It's about passionate people, teams working together, pushing the limits of what's possible.
It's a nice way to end the paper. So, as we wrap up this deep dive into SWE-Lancer, what are your big takeaways? What really stood out to you?
For me, it's the confirmation that AI's role in software development is changing fast. But it's not a simple robots are taking over scenario.
Right.
AI can do certain things really well, but it still doesn't have that big picture understanding, that creativity, the human touch that really makes a great software developer.
I totally agree. The results are really interesting, but they also showed that AI isn't about to put human developers out of a job. What really fascinated me was how AI is approaching these coding challenges. It's not just about spitting out code. It's about analyzing the problem, understanding the nuances, and even taking on these managerial roles like we talked about.
It is. It really is. And that leads to a really interesting question I think our listeners should ponder. What if instead of seeing AI as a threat, yet we embrace it as a tool that can help us become better developers, that can amplify our skills and help us create even more amazing software? That's something I'll be thinking about.
Yeah, it's an exciting and challenging future, and we're all going to be part of shaping it. So, thanks for joining us on this deep dive. We'll be back soon with more explorations into the world of AI and software.